At this time, I'd like to introduce Pierre-Yves Maunier, who will be presenting Deploying a Backbone in APAC. Pierre is a network architect at F5 and is coming to us today from France. This is Pierre-Yves' first time presenting at NANOG, and it's a pleasure to have you on stage with us today.
Thank you.
And there you go.
Hi, everyone. This is not a technical talk. It's just our experience, everything that we've experienced when we've deployed our backbone in APAC. I'll quickly go through who is F5. I promise it's not marketing, it's not a sales pitch. I just want to tell you why we needed a backbone in the first place. And to explain why we wanted to do an APAC deployment, I go quickly through the backbone history to explain how we came up to the need to deploy in APAC, and then I will actually talk about the deployment and summarize. Summarize our experience. Microphone. All right. Who is F5? So you may know us, F5, because of the big IP boxes. We are pretty much known as a hardware or appliance company. That was true a few years back. But it has changed a little bit because over the last few years, we've acquired a few companies to build a services portfolio that I won't detail here. But the thing is, these services from layer 3 to layer 7 needed an underlying infrastructure to perform. So we needed to have a backbone. Regarding the backbone history, so it all started in France, a small startup called Across Networks in France with some French guys who wanted to build a network to do DDoS mitigation differently at the time. And when you want to create a backbone out of France, well, you start with two POPs, the two main POPs to get connectivity there. So we started with two POPs. We quickly expanded to the standard FLAP, Paris, London, Frankfurt, and Amsterdam, and started to connect to the US as more customers were coming in. And as we expanded to the US, we merged with another startup called Volterra, a US startup. Their main customer base were in the US, so we started expanding in the US. And we started to get requests to connect the Asia-Pacific region. And so the next step was to do that. How we deal with that, not problem, but that challenge that we had. So APAC is quite large in terms of geographic distribution. There's a lot to cover. It's very different to what we've been used in Europe and North America in terms of distances, latency. Just to compare all network POPs that are the most distant in Europe are Stockholm and Lisbon, and it's 50 milliseconds to get from one to another. And 50 milliseconds is approximately what you get between Hong Kong and Tokyo. And our closest POP in that region, it's Hong Kong to Singapore, it's 30 milliseconds, it's 4 times what we have between Paris and London. So the order of magnitude is different. The costs are different, and we have two ways to connect this region. Either we go from Europe or from the US. We decided to go from the US because with our requirements in terms of capacity and resilience, it was easier and cheaper to do it from the US. We did have previous knowledge about the APAC region, but not about backbone links. We knew how to deal with transit and peerings because in a previous job, I had to deal with POPs, but islands that were not connected together. Connecting all the POPs together was a new dimension for us. So we were very new to that submarine cable system world. So we wanted something cheap that works, and we decided to go with layer 2 circuit to start. So it was really easy. We had Seattle and San Jose on the west coast of the US. We went with a provider. We prepared some layer 2 circuits, so just MPLS circuits, a ring between Seattle, Tokyo, Singapore, back to San Jose. And we are thinking, as we are not dependent on an underlying submarine cable system, if that cable goes down, it will be rerouted by the provider on something else. And actually, we got the quality that we paid for. It was really cheap, and the ratio between quality and price was good, but it was extremely cheap. So it was really bad, actually. We had a lot of, it was unreliable, packet loss, hard down. We tried to work with the provider to solve these issues, but without success. So after a few months, we started to look at another solution. And we started to say, is it difficult to do it ourselves, to buy our own wavelength, to select our own submarine cables? So we tried that. So we ditched the laser circuits. We bought 10 gig waves, 3 paths per pop. We are saying, all right, 3 different paths, 3 different cable systems. That would be great. It will be perfect. We also studied the terrestrial backhaul to make sure that between the cable landing station and our data centers, we have the diversity. So terrestrial paths were diverse as well as submarine cable systems. But it's not enough. Submarine cable breaks more frequently than terrestrial. And the biggest challenge is that it takes a very long time to repair. When you have a fiber cut on a terrestrial path, it's a matter of hours for having that repaired. When it's underwater on submarine cable, it's days, weeks, months. So you have to take that into account. You can't get the diversity you want with only three cable systems. And the maintenance are more frequent, even though most of the maintenances are impactless. We have to take that into account because you never know. All maintenances can go sideways. So every time we had a notification of maintenance, we had to make sure that how will the network behave should that link goes down. Why so many issues? All right, boats, a lot of them. If you go to the Singapore harbor, it's a very high traffic area in terms of boat traffic. Anchors of boats, fishing nets dragging the ground, etc. You also have the Ring of Fire, so it's a succession of volcanoes all around the region, a lot of geological activity, so that breaks cable all the time. If you want to know more about the causes of submarine cable outages, there's a really nice presentation. If you go on the NANOG website, NANOG 52 on the archives, there's a talk by someone called Richard Kahn, dedicated to fiber cuts on submarine cables. That's really interesting talk. I advise you to have a look at it. So taking all of this into account, we tried to upgrade a little bit. We needed more capacity, more customers coming in. So we added new POPs, trying to get more capacity, up to 4 paths on some POPs. We added Hong Kong POP, but it was not enough. So everything that I've described so far was from Q1 2020 to Q4 2021. So approximately 2 years of working to try to get something that works. In that scenario here, Singapore, even though Singapore has 4 different routes to get to that POP, it went down for 3 hours because the cable G between Hong Kong and Singapore wasn't delivered yet. We had a failure on one cable, the other one went under maintenance, and we have a flap of 3 hours on another one. So Singapore got cut out of the network. In the meantime, the merger that I talked about earlier between Arcturus and Volterra was acquired by F5, and F5 vision about for having services that are reliable in that region wanted to do something better. So we actually went back to the drawing board and reconsider from scratch what should we do to have some reliability, something that works in that region with all the issues we've been seeing. So the first thing that we've done is that we've studied a lot of resources. This is a screenshot from submarinecablemap.com that shows you all the submarine cable systems that are available, that exist. Some of them are not available to buy because either they are full or there's not available for sale because it belongs to a company that uses for their own use. So what we've done is we try to see all the submarine cable systems that were available in the market, and we try to map all the CLS and the countries also. The CLS is a cable landing station. So it's actually the building on each side of the cable, one in the US and one in Japan, for example. This is a building that actually sends the power on the cable to provide power to the repeaters, etc., to the amplifiers, etc. So we mapped out everything to make sure that, and we can see a few things on that diagram here. We wanted to see the CLS diversity. And even though, let's say, you take multiple cable systems, if they land in the same cable system, cable landing station on the land, and that CLS catch fire, you lose both of your submarine capacity. So you have to make sure that you are mainly using two different submarine cables, but you have to check on the land the diversity as well. So that helped us remove some cable that we can't be using because of the diversity issue. And we can see something else here with all the cable systems that we've looked at, that we were able to buy capacity on. Only one out of all these cable systems goes from the US to the Asia-Pac by avoiding Japan. And this was, even the other one are really expensive, but this one was an order of magnitude above that. It was more expensive. So it's difficult to make that fit into your budget. So keep in mind that most of the time when you have a trans-Pacific cable capacity, most of them go through Japan first. We've also mapped out everything on Google Earth to check the diversity that we wanted. We wanted to check the diversity between the cable landing station, the beach manhole. So the beach manhole is that when the actual submarine cable meets the terrestrial fiber before going to the landing station. So we took a lot of time to do that. So after studying everything, we came up with a design where we ditched everything that we had before. We upgraded from a lot of 10 gig waves to mostly 100 gig wave between everything. Now, most of the POPs has 4 different paths, terrestrial and submarine, more diversity. And we added some new POPs because we had more and more business in the region. And on top of that, we were so fed up with all the issues we've had before that we also added a layer 2 backup provider to make sure that even though all the cable goes down at the same time, we'll have some last resort backup route. Not the same provider as the first one we've had issue with, but we were thinking, yeah, this is really last resort. I don't think we will ever use this layer 2 because of the diversity that we have. So this was Q3 2022, so 8 months ago. So we are still running that today, and I want to show you what is the experience of that network today. So like before, outages last forever. So what you see on the right, it's a time series of 8 months. When it's green, the cable is up. When it's red, the cable is not available, it's down. Meaning that you have the first one has been down for more than 6 months already. And I will explain why in a minute. We didn't have any POP downtime like we used to have before, but we had a close call. If you see the small rectangles, the first one, we had 5 different circuits on 4 different paths that was down, and 4 of these circuits were related to our Hong Kong POP. And the thing is, the last circuit that was connected Hong Kong to the rest of our backbone was having CRC error on it. So we actually have 5 circuits on 4 different paths, and none of them we could use them. So thankfully, we were able to use our layer 2 circuit backup to have that POP alive. We did some arrangement because as we went from a lot of 100 gig of capacity to only a couple 10 gigs on layer 2 backup, we had to make some arrangement to reduce the capacity of that POP. So we started to remove anycast, BGP anycast announcement to make sure that we try to divert the traffic on other pubs. But so far, we didn't have any big issue, even though we lost 4 or 5 cable systems during the same time window. But how does this compare to other region? So if I go back to that diagram here, so this is the Asia Pacific, a lot of outages that last for a long time. Trans-Pacific, we have issues as well, a little bit less. Transatlantic, we start to see less issues. North America, less issue as well. The first three circuits are circuits that we just turned up a few weeks ago because we are doing some upgrades in North America, so we don't have the history for this one, but you can see that most of them are pretty reliable. And in Europe, it's almost no issues whatsoever. So yeah, no surprise here. Submarine cable means longer outages. APAC and Trans-Pacific, so everything that goes in the Pacific is problematic. Transatlantic outages last has less issues than usual. I don't know why. Maybe it's easier to repair a cable in the Atlantic Ocean. I don't know why. But yeah, North America and Europe, mostly terrestrial, reliable, and way, way cheaper. So I just want to highlight the fact that the first circuit in Asia-Pac, it's been almost 6 months and it's still down. So you just keep in mind that when you have an issue on the submarine cable, why does it take a long time to repair? First off, you need to have an available boat that can repair the cable system. And the boat may be stationed in a harbor and can take 10 days or 2 weeks to get to the actual fault. And then once the boat gets there, they need to locate the exact location of the fault, which might take some time. They need to wait for good weather condition. If the sea is rough or whatever, they can't act on the cable because they have to get the cable from the bottom of the ocean, bring it to the boat, and repair it and put it back. And for that particular cable that is down for 6 months, it's when the break happened in international waters, it's fairly easy to get all your gears to repair that. But when your cable system go to territorial waters, some countries may give you a hard time to get all the paperwork to be done to give you authorization to get there. So they might not be happy to see a foreign boat in their territorial waters. So that's one of the challenges we are facing right now on this particular link. So on top of that, all the APAC deployments, we've continued to deploy our backbone globally, and you see all the green pubs like Tel Aviv and Dubai are on our roadmap. And we are actually using all the work that we've done in the Asia Pacific, studying all the landing station, diversity, etc. And we are reproducing the same study here. And you can see that in the Middle East, we have the same kind of issue. A lot of cable shares the same fate in the Suez Canal. So most of the connectivity between the US and Asia Pac, most of the connectivity goes through Japan. Then from Europe to Middle East and Asia Pac, most of the connectivity goes through the Suez Canal. So you have to take that into account if you want to at least have some sort of resilience and diversity. Now, what we have learned from all this, so I will just try to summarize everything in a few key points. The Asia Pac is expensive. So today, so if I go back here, so you see this is our entire backbone, and Asia Pac accounts for 50% of all backbone costs. So peering, transit, and backbone circuits, just for that region, represent 50% of our network operating costs. This might change actually now that we are going to Middle East, so it's even more expensive. So we'll see the distribution once we've deployed these pubs. submarine cable outages can last for months. So this increases the probability of having multiple cable systems down at the same time. So in Europe and North America, when you are dealing mostly with terrestrial fibers, you can get away with only 3 paths, because when a dark fiber in terrestrial fiber goes down, it's a matter of hours to be repaired. So you don't have that multiple failures happening at the same time during the same time window. Is very rare in Europe, but in Asia-Pac, you have to take that into account. So you require a lot of diversity. If you want to get close to 100% of availability, you need at least 4 different physical paths to connect each pop between themselves, with the other pops. But even with that, things can still go sideways. We saw that with Hong Kong, even with that level of diversity, all 4 of our circuit were unable to be used, were unusable at the time. So we initially thought that the layer 2 backup that we got was overkill without diversity, and it turns out we used it 3 or 4 times already, even with that diversity we have on the physical path. It was a huge work. It took a long time to do all these studies between CLS, beach manhole, the terrestrial backhaul, etc. But we think it was worth it. Even though we never had any terrestrial issue, the fact that it's very diverse, it gives us some peace of mind, and we just know how to focus only on submarine issues. We know that terrestrial issues won't be a problem for us. And I wanted also to thank all our circuit providers, because we bothered them a lot during meetings to make sure that to modify the terrestrial backhaul, telling them, all right, I like your path, but I want to avoid this street or this crossroad because there is some single point of failure with other cable systems. Even our data center providers were able to give us their physical path for the campus cross connects, to make sure that if we take a cross connect, it will be diverse from our providers' links. So all our providers played the game with us, helping us with that. And one of the last point, shipping hardware, dealing with custom is is difficult all the time, especially in certain countries. Thankfully, we had a team that dealt with that, but this is something that I've learned. I knew it was difficult, but not that difficult. And that's it for me. It was just our experience deploying in APAC, and the final word is like, submarine cable is difficult to deal with. Thank you.